This is our final presentation for Business Intelligence. Our group is Trend May, Erica Texera, Ibrahim Akinsenia, Sohail Kazi, and Janish Patel. We'll be explaining some contents about time series analysis. Some basic definitions: a time series are a series of data that have a constant interval between them, and it can be analyzed in order to see a trend or forecast the future. Perform some other type of analysis is often time dependent. And to measure the quality of our prediction, some metrics are used, like R squared, mean and median absolute error, mean squared error, mean squared logarithm error, and mean absolute percentage error. Time-based indexing is a technique that uses date and time to organize and access our data, so we can select our data in a data frame based on time and date. And this type of data is actually visualized by line graphs or scatter plots or even box plots. Seasonality is when the data shows recurrency, in which the pattern repeats itself in constant intervals. It can be due to weather seasonality of the year or sales because of the holidays and the end of the year. And frequencies happen when the data is uniformly distributed in time, and it can be linked into a frequency, which means the number of observations in that series before the pattern repeats itself. And resampling is a practice that consists of getting recurrent samples from the original data. It can be to a lower frequency, which is downsampling, and to a higher frequency, which is called upsampling. Rolling windows is a similar technique to downsampling, but the data is split into time windows, and each data in a time window uses an aggregated function, and it's used to evaluate the stability of the model and also to forecast the model accuracy. And trends are the general tendency of the data, increasing or decreasing in a time frame, which is shown here in the graph.
Hi, so moving on to the move, smooth, and evaluate functions of time series. So smoothing in machine learning is technique that is used to detect the trends in the time series, and also, and if in case the correcting is required, then we can use that function as well. So moving to the next one, the moving smoothing. So this is a forecasting. This is a technique wherein we forecast a value by using an average of all the past series, and this approach is basically used for series visualization and forecasting. So next part is the exponential smoothing, in which what we do is like we forecast the values by using a weighted average of all values in a time series data, and this method is basically suitable for series which has no trends or seasonality, just like the ARIMA. So coming on to the next two concepts, that is cross validation and how it is implemented in time series. So cross validation is a technique in which we are comparing different machine learning methods in producing a robust model performance. And coming to the application of cross validation in time series, what it does is, in time series the data set is divided into a subset called the training set and the test data set. So if variables are required to be modified, we split the training set into training subset and a validation set. So this model is trained on the training subset and the parameters that minimize error on the validation set that is chosen. So the next thing is, in selecting a parameter to minimize loss function in time series model, we choose a particular algorithm that supports the constraints on the model, and which can be characterized by the three terms P, Q, and D, wherein P is defined as the order for the autoregressive order or autoregression, Q is defined as order for moving average, and D is used for differencing on the time series. On the same thing, fault winters is also another technique or a model in which we predict the behavior of a sequence of values over time in time series, and it is mainly suitable for predicting the both trends and seasonality for forecast.
Hello, I'm explaining econometric approach. So the functions of econometric approach is stationarity, unit root, and autocorrelation. Stationarity means that the statistical properties of a manner of producing a time series do now not alternate through the years. Unit roots. A unit root is a randomly determined trend in a time series. Time series containing unit roots depicts methodical, unpredictable pattern. Autocorrelation, we can define correlation of a signal as a Loiter copy of self as a function of delay.
Hi, so moving to the ARMA and ARIMA model. So ARIMA, which basically stands for Autoregressive Integrated Moving Average, and which is used to predict the time series interval based on the previous historical data which we have. And it has basically the three main components: the P, Q, and D. Wherein P stands for the order for the it's the AR term, which is the autoregressive term, and Q stands for the moving average term, and D is defined for the differencing between them. And ARIMA is mainly used for non-seasonal data and randomly distributed data. So coming to the Sarima, which is on the same scale, it is what it does is it also adds the seasonal component into it, and it converts the non-seasonal data into seasonal data so that it can be we can build a robust time series model. So in this, as you can see here, as it's I have mentioned, so the new additions include the ER autoregression, differencing, and moving average for seasonal part. So these are the hyperparameters that are added to the ARIMA model to make it a Sarima, and the notation is defined as Sarima, the PDQ, and this is the capital PDQ with the M, and wherein the PDQ corresponds to the hyperparameters for which make up the Sarima model. So coming to the ERCH and GARCH models, the time series have a distinguishing trend wherein sometimes the pattern can be very much consistent, and this particular time is called the heteroscedasticity. If the particular type of trend is increasing in a structured way, then that property is called heteroscedasticity, and this is relates to the variance which is not equal across the time series. So what this ERCH model does is what it incorporates the autoregressive component to this changing time series, and EME, this is the moving average component, is added into the ERCH model, and GARCH model is developed. That's why it's called a generalized model, making it as GARCH. Now coming to the linear model on time series.
Hello, my name is Jam and I'm going to present about linear model on time series. So time series data normally has contain too many data, and there are several features that we need to select it to be more easier and simpler to work on a machine learning model. And these steps include feature extraction, feature selection, and feature importance. So feature extraction is to reduce the big data into a much smaller model and just keep the useful feature to and without losing any relevant information in our machine learning model. And the feature important means to identify the importance of the features and rank them and select the most one into the training model. The method in feature important include correlation coefficients, random forest, and gradient boosted machine. And last but not least, and when we extract and we check the importance of the feature, then we will select which one will go to our model. So we will select the one that are most meaningful to the problem we are going to solve, and by using Pearson correlation, chi-square, or regularization, which include ridge regression or lasso regression. And so speaking of regularization, this is the method to add a penalty to different parameters in a model and to reduce the freedom of the model, as well as avoid overfitting. As you can see here, we have underfitting and overfitting chart, and we are trying to get the data in as the show in the middle chart. And there's another method which called SGBoost. It is an open source software library that uses a boosting framework. It's a part of a tree-based algorithm family, and is a very promising evolution to. It's a perfect combination between a software and hardware, and there's so many data scientists are using SGBoost. Yes, so for more information, I highly recommend you search on SGBoost website to get more about documentation and understand more about this platform. So that's about our presentation. Thank you.